Trigonometry is a hugely important mathematical concept which is used in a multitude of fields, including physics, astronomy, geography, and engineering. Today we will be looking at graphing sine and cosine functions and how these concepts apply to real life. Trigonometric graphs can be explained using a unit circle, which is a circle on Cartesian coordinates with a radius of 1. When a certain angle is drawn, the line will intersect the unit circle at a particular y value, which gives the sine theta value. To work out the sine theta values, we can write it out in a table between theta and sine theta. Starting at theta equals 0, we can see that when theta is 0, the y value on the intersection that angle makes is also 0, hence sine 0 is 0. For sine theta is equal to 2 pi over 2, which is equivalent to a 90-degree angle, the angle line intersects the unit circle at the point 0, 1, so with a y value of 1. For sine theta is equal to pi, which is 180 degrees, the angle line intersects the unit circle on the x-axis at the point -1, 0. Hence the y value and the corresponding sine theta value is 0. We can continue this trend to 3 pi on 2, which has an equivalent sine theta value of -1, where it intersects the y value. And for 2 pi, where the angle intersects the unit circle at the point 1, 0, hence sine 2 pi is 0. The graph of sine is drawn with a horizontal and a vertical axis, where the y-axis is y equals sine theta, and the x-axis shows theta in radians, which is the independent variable. For this example, this is situated around the equilibrium, so the point 0, where we can graph the theta and corresponding sine theta values like so, which gives us a wave pattern. Here we match the corresponding sine and sine theta values, noting that the x-axis, so theta, is intercepted at pi and 2 pi. Sine waves aren't limited to 2 pi, they can keep continuing to infinity. A sine wave can be written as y equals a sine bx, and it's characterized by certain factors, including the amplitude and period, and also the phase shift and vertical shift, but we'll focus on amplitude and period. The amplitude, denoted a, refers to the distance from the rest position, so in this case at equilibrium, to the peak of the wave, called a crest. The diagram here shows the sine wave for y equals sine x. We can see the effect of increasing the amplitude, so the a variable, in a sine wave. If the sine function was y equals 2 sine x, the amplitude would shift upwards and stretch the wave vertically in both directions. The period refers to the distance in which the function completes an entire wave and is given by the formula 2 pi over b. We can compare the effect of an increased period here. Increasing the b factor in the equation, so y equals sine 2x, reduces the period as it's on the denominator, as shown here, where the x-axis is now intercepted at pi over 2 instead of at pi, as it is with y equals sine x. A sine wave, often called a sinusoidal wave, is a largely common occurrence in nature. An example is sound waves, which take the form of sinusoidal waves, and different pitches are characterized by variations in the period of the wave, which is often referred to as the frequency. For example, middle C has a sine function of y equals sine 261 2 pi x, and a higher note A has the sine wave function of y equals sine 440 2 pi x, with a larger B value, hence a smaller period, hence the frequency is higher, resulting in a higher pitch note. The amplitude of a sine wave is largely related to the volume of a sound wave, where an increase in vibration increases the amplitude, which often correlates to increased volume. Ocean waves may also be approximated mathematically by a sine wave, especially for waves of low amplitude with smooth and regular oscillation. Oceanographers describe ocean waves in similar ways that mathematicians describe a sine wave, which is described as a transverse wave, using the wave period, amplitude, and wavelength, so the distance between two peaks. Using mathematical models of sine waves, oceanographers can determine the speed of an ocean wave, which is called celerity, by dividing the wavelength by the period, and the amplitude of a sine wave describes the wave height. Sine waves are an intrinsic part of the world around us, and as a core mathematical concept, have a variety of uses and important applications.